Here's problem 1321. A projectile is launched from the surface of a planet, mass m, radius r. What minimum launch speed is required if the projectile is to rise to a height of 2r above the surface of the planet? Disregard any dissipative effects of the atmosphere. So if we had a planet, radius r, and we are to launch a projectile or a satellite from the planet, it's not in orbit to begin with, so its gravitational potential energy is strictly that based on position, and that is going to be our initial position, and then we are going to achieve a position that is not r but actually 2r above the surface of the planet, and that will be our final position, again not in a stable orbit. So our total radius is going to be 3r away from the planet in our final position. Alright, so as we look at the initial energy, our initial energy is going to be kinetic plus gravitational potential energy. So it's going to be 1/2 mass times velocity squared as we're launching off the planet, plus our gravitational potential energy at that point, which is going to be a negative g m little m over r, which is our distance from the planet. In other words, we're at the radius of the planet when we start off. Our final energy is simply going to be our gravitational potential energy at that point, which is going to be negative g m over 3r, because that's our distance from the planet at that point. We have no kinetic energy at that point because we just barely got there. So our initial energy should equal our final energy, and what we have then is 1/2 mass times our launch velocity squared plus our initial potential energy, which is going to be negative g m over r, is equal to our final energy, which is a negative g m over 3r. Masses cancel out for the satellite in all terms. So now we have 1/2 velocity squared is going to equal a negative g mass of the planet over 3r, and then as we plus a gm over r to both sides. So if we factor out a gm over r on the right, we have gm over r 1 minus 1/3, and that is going to be equal to 2/3 gm over r. Sounds good. Multiply both sides by 2, so we have the velocity squared is equal to 4 gm over 3r. Hence our launch velocity will be the square root of all that. So our velocity will be equal to 4 gm over 3r square root. That is our answer. That's the launch we need in order to get to that height. Not a stable orbit, but just a height above the planet of 2r. So our answer is A.